Hi, Kat here for Lightwave Digital. In this video, we're going to be talking about how to put together a scene that gets a little bit more interesting with the different types of physics objects that can be used with Lightwave Flow. In the end, we can produce a scene such as this, where we have like a bathtub object being filled with a large amount of water very quickly, and then continuing to fill up using another emitter. Great example of this that I actually rendered out, but had a couple of errors in it, which I'll go over in a second, and how to correct them. Was this render that I did here. While working with the GUI preset, I decided to fill up the same bathtub and have a little beach ball in there with some kind of source of slime that would continue to fill the tub up. And of course, over time, once it does fill up, push the beach ball out. But I was able to improve on this using the watering setting. So let's get into that now. All right, here's our scene with flow in it. We see we've got a couple of different things going on here that we haven't touched on before. First of all, let's open up the Lightwave Flow interface and take a look at what's actually inside here. We've got several objects in here. First off, we've got our tub, which is a very simple 28 polygon piece of geometry. It probably could be a little bit more sliced up just for accuracy, but for right now, it does what it needs to do. We've got our sphere, which is bouncing and bobbing up and down. And we've got a generator for a large amount of water. That's working with a different fluid type than we've looked at before. We've got our water spout, which we already have taken a look at, but we notice that it doesn't turn on right away. There's some animation going on there, so we're going to talk about that. And then, of course, something for water to splash onto in case we get an overspill or an overflow. All right, so going down the top of the list, let's take a look at the physics tab and take a look at what each one of these are for the body type. Pretty straightforward for this one. It's a kinematic object, which means it's just going to basically sit there. It's not going to do anything but have fluids interact with it rather than it interact with other objects. We can animate it, we can move it around. And we've got our water spout, which is an emitter. And we've got an envelope on this. And the reason why I've got an envelope on this is because I didn't want it to start right away. I wanted to, have the fluid block generator generate first, get in there, and then drop the ball on top, and then get this spout to go. And that's achieved through using the speed control with an envelope. And the reason why it's offset is very, very simple. The development for this is a little bit early, and there doesn't seem to be a hard check at some points if you have an envelope, so that if you have this particular keyframe at 0, it might not read. So let's see if I can get it to do it here. Well, it doesn't seem to want to do it here, but what might happen in some cases, let's just blow this envelope away and reestablish it. So we'll go envelope again. What will happen in some cases is that it won't catch that keyframe and it'll emit, and then in the next frame it understands that there was a keyframe set to 0, and it won't emit fluid again until the next keyframes tell it. But if you have one at 0, sometimes it doesn't pick up on it. So we'll try it at 0% for value, and we'll go and kick in keyframe, say 10 frames, also at 0, and then 11 frames. And we'll have this at 120%. Okay, we'll just straighten out the splines here and see if we can get it to do that weird thing. Reset. Now it seems to be okay. But if you ever do get into a situation where it's starting to generate on the frame 0 when there actually is no data that you want to be spitting out of your emitter, just simply move the first frame off a little bit if you can, and it'll work just fine. But this means that you can turn spouts on and off, or vary them over time. So, for example, if I want to just punch in some more keys here, we can do that very easily. We can use a modifier, expression. Basically, we could say, hey, if you want to get closer to an object, you're going to spray less. If you get further away, you're going to spray more. Stuff like that. Noisy channel on top of this if you wanted. All kinds of different things. So let's hit run here. That'll actually help with the stream of water. So it's not so static, even though it is a stream of water coming out. And let's move on to the water block for the tub. This is the fluid block. Effectively, any shape that you have, as long as it's rectangular or square, can be turned into a large block of water very quickly, and it will do what it needs to do for you as a volume filler, but you got to be careful with it. Depending on the size of the emission and your particle size, if you emit stuff right away, the particles are going to start to connect with each other, and it'll immediately, almost the moment that you hit simulate, start to combine into that liquid block and start to push out from its confines. So you can't have this as conform to the edge of an object as much as you probably like it without it causing problems potentially. So let me just drop this a little bit further down, and we'll reset, and then we'll hit run. This is probably a little bit better, but if I had the larger block, it would be an issue for sure. Trying to get it to line up with everything. So this is going to be a combination of like your particle size, and in the more simulations tab, how much of a kinematic margin you have, and of course particle margin. So be careful with this. It can't be, right to the edge. This is obviously a lot smaller than I probably could get away with, but another thing you need to be aware of, at least for now, hopefully this will be addressed in the future, is that if you scale your block, you might not actually get what you're looking for. Or if you rotate it, it doesn't seem to understand things like rotation. So let's take this block and rotate it this way and run it. Bring this back up a little bit. Rotate it again. Doesn't really seem to understand those types of coordinate changes. So a bit of a limitation right now, but hopefully this will get addressed in the future. And hopefully it's not something that's like a restriction or a limitation of the Newtonian libraries. But I'm pretty sure that this is just something that needs to be improved on in future versions. But keeping that in mind, it's best to size this up, or scale it as you need it at modeler and deal with it that way. And then just run the simulation from there if you need to fill up a large container, like, container of ice cream, mouthwash bottle, whatever it might be, very, very quickly. And of course, be cognizant of the particle margins and the kinematic margins, because when you do run this, the thing you're going to be looking for is how close to the edge does this stuff get inside of the container. And is it actually going right to the edge? Is it spilling out because the particle size is too small? Are we having issues with other factors? So let's go 8.5. We change that particle size, and immediately we've got a big explosion because all those particles are instantaneously larger than their original setting. And now we've got an overflowing tub, but now we've got water that's a little bit more conforming to the tub. Let's bump that out. Dial in our vision distance. Let's go 0.09. Probably good. Yes, I know I've got stuff leaking out of the bottom. That has more to do with the shape of this tub and just various settings in here. I could spend probably a good 20 minutes going through each one of these things to get it to work a little bit better. But it's really going to come down to is particle size and, if necessary, a couple of additional sub steps and the iterations for it to resolve those problems. But let's talk about the next thing, which we haven't talked about before, which is the actual sphere. The physics for the sphere, it's just a rigid body type, but we can now define how much mass. And in this case, when you're working with it in a situation like that, you can also think of it as buoyancy, even though that isn't correct. But people don't really think of, oh well, mass. I want it to float on top of the water, or this much on top of the water. How much is it going to float? So think of this as something that can work with values that are really extreme, or on the flip side, very minimal. Probably wondering what all these little blue dots are on this. Well, it's basically just the representation of the mesh as defined by the particle spacing factor. So if we go like 0.5, 5, you can see we've got less particles and there's more space between them, which means that the ball is going to perform quite differently. Now we've got a situation where liquid could very easily be interfering with that ball in a completely different way than what we would understand because there's more space, there's more interaction through the ball or through the sphere than we would normally have. So going down to something like 1.5 and resetting it. It's a little bit more animated, it's a bit more bouncy, but there's still enough particles on the mesh or being evaluated by the physics engine to accurately interact with the water and also any of the other objects in here, like this kinematic tub and or another rigid object. While the flow plugin is intended to work for doing liquids like this, it can also be used for doing hard body physics. And indeed, when you work something like this in with a rigid object, yes, you're generating your object sequence with your fluid or your liquid, but what about the actual object? If you want to go and render this later in a network environment, you're going to have to bake the keyframes out for your rigid objects. And that way, they will understand what to do over the network without any calculations or evaluations. You can also bake out the keyframes, bake it out to an MDD, that sort of thing. Because when you actually load a scene back in where you've done a simulation like this, and Flow is just doing the sequence of the liquid, you're not going to get animation on this guy because it doesn't know what's happened. So unless you want to rerun your simulation and bake everything again, you're not going to get very far very quick. Okay, let's reset this and bake it. So I think we've got something that kind of works for us. Run. Overwrite those objects. You see that our tap is a little bit more animated now because we've got that envelope on there with a bunch of different keyframes plus the noisy generator. I didn't make any changes to the default fluid settings. So this is just as it is right out of the box. But it's a good demonstration of how you can have multiple objects in here or multiple items and have the liquid interact with rigid and obviously be interfered with or blocked by kinematic physics types. Just change to wireframe here. Help on my poor computer. If you're really careful, you can probably hear my computer speeding up in the background as we bake this stuff out. But it's going at a pretty good clip. And yes, this is using the GPU. It is CUDA enabled, so this is actually working with my 4060 Ti. Sorry, Mac people, but this is something that is a PC only deal with this library set at this time. And of course, that's just how it is. So if you are on the Mac, the M4, you're unfortunately not going to get access to this tool. However, there may be some way for us to figure out how to do that in the future, but for right now, this is a PC only function. So it's always good to have a PC. Let this go to 300 frames. So far, so good. I can pause it now. I got 300 frames roughly. So we'll make a preview here. Very cool stuff. The emitter for the fluid block instantaneously generated, goes in, great. Ball precedes it, floats on top of the surface, and we've got our tap which turns on after a certain amount of frames. So we've got quite a lot going on here, but very, very simplistic demonstration. But with a little bit of creative effort, this is no longer a bathtub. It's a wavy ocean or something like that, and we can put a boat in here or a rubber ducky. You have little rubber ducky wars or something to that effect. All right. Well, hopefully you got some additional information and some inspiration on what you can do with Lightwave Flow. We'll be back in another video to talk about a few additional functions and features and setups that you can try at home.